detail, I'm Vincenzo Marivitale. You can call me, as also Lara said before, Enzo. I work in Toulouse in France for Ansys, France, and I work as application engineer for STK, in particular for aeronautics and defense topics. So today we are going to show just a little use case in which we are considering to generate a constellation for imaging, a little constellation for imaging, in which we will try to understand the access time for a multi-op link and the coverage over the area. So we will first create our scenario, and well, as name, we will consider to put image underscore workshop. And well, we can consider today, and the first thing that we can notice here is that the scenario will be set up under a defined location, but in particular defined the start and stop of the event. And in particular, the stop can not only take the dates, but we can even take periods, duration, in which STK will take care of compute the final timestamp of the analysis. So in this case, we want a really long analysis in order to understand how many accesses we can have over a period. And we can consider 21 days. So STK does not only require to use the timestamp, as I said before, for example, in TCG, but we can select a date, but also a duration that stands over this set of units of measure. In this particular case, we are using the time duration, in which for day, we are just defining directly the day, but we can define hours, seconds, months, years as we want. So in this case, we already set up everything. We can even enter a description, which is not mandatory for us, but we can write, for example, well, let's calculate how many access we have. Okay, just as soon we press OK, the interface will just readapt itself in order to start the scenario analysis. And we can set up our own, I call it workbench, our graphical user interface at our own necessity. In this case, for me, for example, I can tile vertically the interface in order to have a good situational awareness in the 3D graphics as well for the 2D graphics. And since we are considering to analyze just the coverage in terms of our architecture, how we'll cover the area, we are not considering the feature of the terrain. So technically, the terrain information will not be necessary for our own purpose. In this case, we can open the scenario settings, which allow us to define in general how the scenario and the analysis will work. So we can open it, and as well as the terrain, which will host our option, in which we will disable the use terrain server for analysis. We can even set up different other other option that starts from the time towards even the attributes in the graphics, in the 2D graphics, and in 3D graphics. In case you need to set up a telecommunication analysis, so an RF analysis, it can be even important to set up your own environment in RF. So we can toggle off the terrain server here. In particular, the terrain server will use the AGI SEDS, the geospatial content server that is freely given by AGI for the entire world. And after that, we can press apply, and we can just do a little walk towards the main options that we have inside the scenario properties. In particular, can be useful units. Units defines all the standard units that STK uses in its analysis and in its graphing of the mission. In particular, you can see that all the units that we are using currently are mostly SE, but you can change by your own purpose or your own comfort by using the large set of units that STK puts as available. You can define angles, ratio, for example, for the RS communication in particular is in decibel, but you can set up even as linear units, the frequency, bandwidth, and so on. So in case maybe you don't want to use directly the UTCG timestamp, you can change the date format to the epoch second, for example. But in this case, we will keep everything as standard because we don't have particular necessities for our scenario. And later on, if case we will return back in these scenario properties, but we can define the 2D global attributes and the 3D global attributes. And as I said before, in case of an RF analysis, which will not be the case for today, we can set up our environment as which model, propagation model we will use, starting from our environment, but also rain, cloud, and fog, atmospheric absorption, urban and terrestrial, troposcintillation, ionofading, and in case your own custom models, in case you have. So after setting up the terrain, we can pass to start the definition of our scenario. In particular, since I live here in France, I would like to consider the idea to analyze the coverage of an hypothetical set of satellites that are sent in space for imaging of the French region. So the first thing I can do is like to insert an object using this button here. And this will will open us the insert STK object dialog, which is based on two different selection. The first selection is which object you want to insert, and in this case is the area target. But of course, STK is fully plenty of methods in how can be set up an object. In this case, for an area target and for the French region, it can be highly useful to use the dialog select countries and US states. In this case, STK will take care of defining the borders of the country that we need to analyze, and we can add the French region. Just a little note before continuing. STK, for the ones that are approaching STK for the first time, it's worth saying that the STK scenario is divided into scenario objects and attached objects. The scenario objects are like the first level of objects that can be hosted inside our scenario. So, for example, we can have an aircraft, a ground vehicle, a launch vehicle, or a satellite, but even celestial bodies, or groups of objects, like the constellation or the satellite collection, or particular analysis, like coverage definition and volumetric. While the attached objects, it often refers on a specific type of analysis, like attitude coverage or figure of merit, while also particular payloads like antenna, receiver, transmitter, sensor, and radar. So for this case, we can go towards the area target, select countries and US states, which is our first selection, and we can press insert. The new dialog will request us to select one or more countries that we need. So in this case, we can select the French region. Technically, we could even add over to the France Métropolitaine also the Domaine d'Outre-mer. But we will just keep with the main region, so we can keep just with France. And in case we would like to add all to insert all the areas, we can just toggle and select all areas. In this case, we click insert, and we have France. The area target comes like a set of points, in this case already preloaded by STK, but a set of points that can be defined or as ellipses or as a pattern. In this case, every country is set up as a pattern based up to a set of boundary points. For example, France requires 3096 boundary points, but we can have different other countries that will require more or less based on the necessity. But this is just important in order to define our country here. So after that, let's consider the idea that the site that will collect the image, well, is not in France, but is in another country. For example, we can consider to add white sands that is in US. So by inserting again the object, we can select our facility simply by selecting the scenario object facility here. And we have, as usual, a set of methods like from shapefile, from facility file, in case you have already registered your own facility. But in particular, we can select from a standard object database that is given by AGI itself. AGI hosts as a database a set of facilities, cities, which are under the place object, and also satellites that you can easily access by the standard object database. In this case, I can see that we can query our database just by clicking insert. This will open the interface, which will tell you as first that we are requesting a facility, and the data source that we will use, which is toggable in this case, are online and local. STK as installation is bundled with a set of local elements, local objects that can be expanded also with the online collection. So in this case, I just recall well the name, but I can even find the white sands, and I can show you that technically we can define even the role, which is a ground station, and the country, which is United States. We can define the status, the altitude, and we can query in a very detailed way the facility that we want. So in this case, we can just press search, and we have, well, a lot of facilities, because there are several over the US. In particular, we can take the view WH3K, which I can insert with a defined color that for default was blue today, but we can select like orange and click insert. When we download a file from that recalls a defined object, like for example, a facilities, we not not only download the information about the position itself, but sometimes if it's available, we can even download other extra information. Like, for example, in this case, we can see that we have an azimuth elevation mask. The azimuth elevation mask is an extra file that is declared inside basic azimuth elevation mask and is a .aem. The .aem is a custom file that will host inside the azimuth elevation for the range in which is visible the range in which the facility can have contact with a potential satellite. We will keep these, and we can see in both 2D graphics and 3D graphics that the facility itself will have a sort of volume, mask over it, which will define from which angle to which angle will not have connection and or will have the connection. After that, we can proceed to set up our imaging constellation. So we return back to the home view, and we can see first we have our facility, and then we have our region of interest. So after that, we can add our satellite. In this case, we want to add 2 satellites that we will call image satellite with a proper number, so a progressive number 1, 2. And by clicking inserting object and going towards satellite, we can select among all the methods Orbit Wizard. Orbit Wizard is a tool that helps you in STK to define easily, without entering inside the definition of the TLE, the orbit, the potential orbit of your satellite. So in this case, we can do some modification. In this case, I will keep as easy a type circular orbit, but we can have also a critical inclined sun sync or standard. A geosynchronous, Molnaya, we can define our own orbit, a repeating ground trace that we can just see, a repeating sun sync and sun synchronous. We can select which one we want, and we can even modify by scrolling the toggles or defining a proper information like the perigee altitude, the argument of the perigee, and STK will take care of define the orbit for you. In this case, we said a circular orbit in which we can even change the altitude, for example, but for me, the altitude will be 500 with an inclination of 68. And we will just space a bit the run. So the run for this case will be 105. And as soon as I change the field, I can see that I have the first satellite here, and I can name EMG satellite 1. Let's color in red, and I click OK. So this is our satellite, which is being propagated from now, so 28 November 2024 at 11, towards the entire scenario. And we can see that it's changing during the period. Okay, we can add a second one like we considered before, and we will add a satellite Orbit Wizard, and in a same fashion, EMG satellite 2 with an inclination of 68 again. We will just replicate the same type, the same definition, but just changing the run of 5 degrees, 110 degrees. And I can even click apply, and we can see that we have our satellites that are going from White Sands and are returning in Europe. We can animate, and in both the 2D graphics and the 3D graphics, the satellites will orbit over the area. We can see that even the panels will move oriented by the vector of the sun. And we can see that they are, I can say in terms in an aeronautical way, an information. So after that, we have the satellites, but we don't have the payload for now. So for the payload, we just want to set up a sensor that will replicate the field of view of the imaging payload. And in this case, we can add a sensor and then copy to the other satellite in order to replicate it. So I can insert an object. And in this case, I will add just a default sensor, which is an attached object. And I will add to image sat1. The sensor comes like as default as sensor 1, and we can rename it as image FOV1. We have several ways of defining a sensor, starting from the complex conic towards the simple conic, and even we have SIR and EOIR, which will permit us to analyze for the SIR, analyze the radar performance of our synthetic aperture radar, or EOIR will permit us to have the synthetic scene of an electro-optic infrared sensor. Like, for example, we can define spatial, spectral, optical, and radiometric information. In this case, we will just use a rectangular sensor in which we will define the vertical alpha angle as 25 degrees. So we will have an aperture of 50 degrees, while the horizontal will be 7.5. So a width of 15. I will click apply. Maybe I will change the color by just double click on the color itself, and I will put as yellow, and I can zoom to the satellite. The satellite now will have a field of view, a broad field of view that comes from the center of the model and intersect the Earth surface. So after that, since the payload is the same, we assume it is the same, we can just copy and paste in image sat2. This will replicate the sensor immediately with changing also the name to image sat2. And we can even animate and see how the field of views are acting during the passages. So as soon as we generated our minimal version of the payloads, and we have also our region of interest and our facility, our idea is now to find a way how to connect the satellites to the facility, the imaging facility that we have in US. And the only way that we have for now is like generating a constellation that we will help us to relay will help us as role of relay to connect in a multi-hop link from image SAT1 and image SAT2 to white sands. So in this case, we will consider to use already available, already in space satellite that are the TDRS, and we can add the satellite as we did before for the facilities. So using standard object database. So by inserting an STK object, we can click on the satellite, and instead of using Orbit Wizard, we will recall the method from standard object database, and we will click insert. This will help us to search the spacecraft in this case, as we defined, as we noticed before, and from the data sources online and local. In this case, we can query our database by defining which mission they are doing, or the launch site from where they started their mission, and launch date, periapsis altitude, and other parameters that might be interesting to take care. We can even query our object to check if they have object extension, so attached object as children, like transmitter, receiver, optical sensor, antenna, or radar imaging sensor. In this case, we will just write TDRS as name or ID, and I will check all the satellites that have an operational status. And I click search. So we can even download all these ones and add to our mission. But in this case, since we are just performing the analysis over white sands WH3K, we will use just the third one, the fifth one, the sixth one, the 12 and 13. And we will just change the color to fuchsia, for example, and we can create even a constellation which will regroup all the satellites in a single object. So for create constellation, we will have inside the reference of the satellites, and will be very useful in order to set up our chain later. So for this case, we will call it TDRS SATS, and we can click insert. This can take, of course, it depends by the connection, but the file itself are very, very little. So it's just a question of waiting the propagation of each of the satellites, which we are already at the fourth one. The fifth one is ready here. And well, we have all the satellites now, and you can see that our satellites are propagated around the globe as geo, and well, over to noticing that we have our propagation of the satellites and over also the image sat, we can see that some of the objects, they have a full set of transmitter, receiver, and antenna information. In this case, you can even perform for some of the satellites communication analysis, but you can even extend the communication over also to the others by just copying and paste, for example, the entire set of satellites, the entire set of payload to the other satellites. In this case, we will just consider the position of the satellites over to the link budget. So by using the position of the satellites, we can perform a chain objects by seeing the visibility from a satellite to another satellite. But in this case, I may say that we have a lot of clutter and we don't have probably the correct information over the correct information, the showing of the useful information over the 3D graphics. So before continuing, we might toggle off the ground tracks and the orbits for all the satellites and just extend the names of the satellite for a longer viewing distance. So in this case, we can modify, we can have, technically we have two ways to do it, or just selecting one by one, which can be stressing to change the properties by one, or just select by category, in which with a control click, I can select all my satellites and click properties. In this case, STK will take care to regroup all the properties that are in common between the objects. So for this case, we can extend, for example, the names by clicking in the model. And we have detailed threshold over also the possibility to change the marker geometry and origin, the model, and the size of the model. But in this case, we just need to have the information about the simple model, the marker, and the point from all the distance of view. In this case, we can see that in the 3D graphics, the names are shown on. But in general, for the scenario, we don't need in particular this, the propagation of the orbits, since we are just we want to just appreciate the multi-op linking. In this case, we can open the scenario properties itself and return back to the 2D graphics in global attributes, in which you have the possibility to toggle off the ground tracks and the orbits for each of the vehicles. And I can click apply, and now it's more useful, the view, in order to understand where is the position of each satellite. And we just need to do the same for the facility. Just I notice it now. So I can click just in the model and do the same. Okay, simple model level. Click OK. Now we have all the names of all our elements that are available inside our scenario. So before performing other and going towards the chain setup, I think we need to regroup the satellite, the field of view, inside the constellation in order to have an easy management of the chain setup. So I can add two other constellation as default. So I will insert twice a constellation, which can be inserted always by insert STK object, constellation 1 and constellation 2. And I can rename them like image sats and image field of view. No, maybe better camera field of view. Okay, so we can open the first one, EMG sats, and we can double select image sats 1 and image sat 2, and we can assign the objects. In this case, the constellation will have inside its information the reference to the ImageSat1 object and ImageSat2 object. And similarly, we can do for the sensors. So I can open camera FOVs and I can select by, for example, a selection filter with the sensor clicked here, and I can assign directly the object to the constellation camera FOVs. After that, what we are going to perform is the setup of the chain. And the groups that we generated, called the constellation, will help us to tell to the chain object to analyze and check, in which case we have a connection between all the assets that starts from the region France, will use, for example, a defined payload of a defined image sat, and then we'll connect to a set of TDRS1 or more TDRS5. In this case, we will consider up to 2 relays, and we'll connect at the end towards white sands. So in order to set up this chain, we can insert the object as usual, and we can add a chain default or define properties. If we click define properties, the properties will be open immediately as soon as the standard of the default object is generated. In this case, we can see that we have several interfaces here, which have several voices inside this interface, which is the start and the end object, which will be the global start object and end object, the maximum number of objects that will be involved inside one strand. In this case, we are considering unique objects. So it means that if you are trying to connect twice to an object, it will count as one single object. Then we have the connection panel, in which we can restrict, we can add per each connection a from and to object. So from which object we will start the connection to which object we will end, the minimum and maximum number of uses, and eventual platform restriction. In this case, we can start by considering the idea of adding as global object France, and as end object white sands. As first connection, we can add our area target, France, and we say as soon as my region is, as soon one of the camera falls will go over the area target. So as soon we have one of the 2 camera FOVs, so we will use the constellation, and we say maximum number of use 1, we can use this one. Just start to consider the assets as available. So we will consider France to camera FOV is available. Now we can extend from camera FOVs to image sat. So practically connect to the satellite, the relative satellite. As soon as we have this connection, we will demand the image satellites to connect to one of the TDRS satellites. And so we will add TDRS SATs constellation. In this case, we might even add directly, okay, just consider to end the connection to white sands, but we can add even a potential second connection to the TDRS-SATs, so a relaying between one relay satellite to another relay satellite. And in this case, we can just add another connection from TDRS-SATs to the other TRS-SATs. In this case, one of the satellites we connect to one of the others. And we can set even the maximum and the minimum number of usage. In this case, we will keep one. And as last connection, we can extend towards our facility. So now the chain is generated, and I can click apply. And as soon as we applied, of course, the compute is not generated. We need to enable the compute. So first of all, we can define just a name for these. So imagery chain. And then left click chain, compute access. Okay. We can open now the reporting graph manager and see how many assets we have by clicking complete chain access. And we can click generate. We have up to now 51 accesses that have a duration of from I can say 31 minimum duration to 187 with a mean duration of 135 seconds. But in this case, we are considering maybe situation in which we have like hours that cannot be acceptable for an imaging situation, like 23 hours. So we can constrain our in order to simulate the light and the penumbra situation inside our area target. We can constrain to the local hours. So we can consider to add a constraint in active and add a new constraint. In this case, we will use the local time, and I will click add. As we can see in this, we don't have so many constraints inside the area of target, but we can like show another object later on in which we can see how many constraint STK can help you to set up in order to optimize your analysis. In this case, we consider as local time in France between 9 hours to 16 hours. We have the possibility to use a maximum time step as also to consider this set of time as exclusion and not as inclusion. But in this case, if the access in the local time of France is between 9 hours, 16 hours, the access will be acceptable. So I will click apply now. And we can recall back our report. So we go to reporting graph manager, and we can recall from my favorites because I opened it before, complete chain access. In this case, from 51, we have just 18 connection, in which technically the mean duration has risen up, but we have of course, in general, less time. We have 2,621 seconds in which we can have a connection. So after that, we can, for example, take the first timestamp in order to see which connection we have in that period. And as soon as we start, we can see that STK computed all the potential multi-op links that we can have from the satellites. In this case, we have image sat2 that is that entered inside our area target from the north, from Bretagne, and is trying to connect to several TDRS, and the TDRS have several connection towards white sands and between them. In this case, we can say that maybe it's not the best idea. It's very graphic, this view, but we can request again a report and graph manager in which we can analyze the individual strands. So we can ask a report, individual strand access, in which we have all the potential accesses from France to white sands defined by start time and stop time, and you can see all the potential assets that are connected between them. In this case, we are going from France to the first image satellite towards the TDRS3 and TDRS6 to white sands. But of course, we don't need so many connections. We need just our optimal connection. And let's imagine to request the optimal connection that is in duration. So in this case, we can open the imagery chain back again, and we will ask an optimal strand analysis. In this case, let's compute by distance with a sample time step of 10 seconds and strand to store 1. And I will click apply. This case has best distance. We have from image sat2 towards the TDRS12 to white sands. And even these can be shown in the report and graph manager, like optimal strand at time. And we have time by time all the potential strand that have as best value that have the best distance achieved time by time. But in this case, we can also set the processing delay, clicking apply. This case is the same, but we can set our own scalar calculation. Like for example, we can set up in analysis workbench another metric based on the potential parameter of carrier over noise, for example, just guessing, or the error bit over noise, the BER. It's up to you. Depends by the logic you want to integrate. In this case, we will keep distance as default for our training purpose. And after this, we can see, after the analysis of the chain, we can see the analysis of the coverage over the area. In this case, we can generate, for example, two coverage that are the most frequent coverages that are done for an imagery satellite or for a NERT survey satellite, which are the age of data and the ground sampling distance. In this case, we toggle off the imagery chain because it's not necessary anymore. And we can add to our scenario. Okay. Oh, forgot to save it. Okay. We can add to our scenario a coverage definition. The coverage definition sets up the parameters in which STK will operate in order to analyze the coverage based on the figure of merit that you want to analyze. So we will insert a default coverage definition, and we will call cov def image. Cov def image actually is set up as default as latitude bounds, but we can select also as global, and the points, the grid points will be set up accordingly. But in particular for our needs, we need to set up a custom region as area target. And we will select France. Of course, France has a little extension, so I need to lower the point granularity. I will consider 0.5 and a point altitude of 0.1. Yeah. And I will click apply. Now the points are all on the French region. And we can, since we are not interested in where the points are, we can toggle off them because they are cluttering. Okay. And we can set which asset or set of assets will concur to the coverage estimation. And in this case, we can enter inside asset properties, which is here. And we will select the camera FOVs constellation, which will set as assigned all the sensors that are inside that constellation. So we can or double click or click assign will be the same, and we can click apply. As soon as we do like that, the computation is still not over. So we need, it's still not started at all. We need to request as we did for the chain. So left click, coverage definition, compute access. And in the lower corner, you will have the progressing of the computation. Of course, the computation now is done, but in order to see the metrics, we need to attach an object to coverage definition image that is called figure of merit. So we will insert an object, and we will add a figure of merit over coverage definition image, and we will click insert to coverage definition image. Okay, and you can see that now the color is all violet fuchsia, and this means that the area has been computed because as is a simple coverage, this one, but let's rename it as age of data. I will click OK. And from the definition, instead of simple coverage, we will set up simply age of data that is by default given, and we will consider the average. Of course, we want to set up for analyzing for understanding the analysis, we want to set up some levels of analysis. But in this case, we need first to understand in which boundaries our edge of data is working. So our figure of merit is working. So we will click Apply. And we will see in Report and Graph Manager the grid stats. We can see that our minimum is a 46,751 seconds to a maximum. In this case, we can even change from seconds to minutes, maybe it's better. Okay, we can see that the age of data is 779 minutes to 3,813 minutes, with an average of 1,896. Of course, this for training purpose, this constellation is not the best performing, but we can have a good use case for the potential real case that you can have in your workflow. So in this case, considering the minimum and the maximum that we noticed, we can set up an animation contour that starts and stops between these boundaries with a defined step. So in this case, we had 779 minutes, so 770 to stay large, towards the 3,800, so 3,600, 3,700 minutes. And we will consider a step of, this case, 500 minutes. We'll add the levels. We have 6 levels. And I can set the color explicitly level by level, but I can even set a color ramp as default, and which goes from blue to red, for example. And I can even set up a legend. For the legend, of course, we need first to apply. Okay. And for the legend, we can set up our own layout. In this case, for example, it's better to put it vertical, minimum to maximum. Yes, it's nice. We can show at location the 3D graphics window, and we can remove the digits. We can just put the scientific notation, for example, age of data seconds. And that's all. That's nice. Yes, and we have our legend in the upper corner as we requested. So now we have a good time step that we can see in the lower corner here that I decreased by using the palette here. We can have decrease time step, increase time step, and we can see that since it's an animation of the is an animation figure of an animated figure of merit. We can see that the color is changing time by time, and we can even set up zoom to France and show the variation time by time. And at each passage will change the color. But over to this figure of merit, we can even do this the ground sampling distance. And in this case, it will work Similarly, we will just insert a default object again, called figure of merit. In this case, we will call it GSD. And we will ask from our access constraint, we will ask the ground sample distance here. We can leave everything as default, and we can ask also for current time, and we can show the contours between 0 and 7. Just now I'm just guessing potential values, but I can even see, okay, from the report and graph manager, always grid stats generates, and we see that we have a minimum of 5.33 meters to a maximum to 6.09. We can do 5 to 7, yes. So 5 to 7, and with a step of 0.2. And we can add the levels from blue to red is fine. Natural medium sampling. This will permit us to have the interconnection of the contour. Click apply. Okay. Okay. And then we can even set a legend, but this is not. Let me check if I did something wrong. 7. Step 0.2, and okay. Okay, sorry. I needed to do static because in animation, of course, this is a static one. And I can generate even here the legend as we want. This we can leave one single, it's perfect as it, and we can write GSD meters. Okay, and shot pixel location. Apply. Okay, and so we have also our other figure of merit. We can toggle from them to them, select the imagery chain, and for example, to have a better awareness of the events, we can even add the image chain time intervals that we have seen inside our report by clicking the add time components here, and selecting the imagery chain, we can select complete chain access intervals, which is the list of intervals that we have seen inside the report. So we can click apply, and we can see we have a full set of little stripes here, which are the events in which we have the connection. So if we point, well, okay, just up, yes, and let's try like that. Okay, we have the first one, and then the following ones that we can even take from the report to have the values, because here the pan is very difficult to do this case. So complete chain access. We can take like the third one. And we have again this other chain. So I think I finished the points for me for the scenario. So I'm open to question.
Hi, Enzo.
Hi, Lara.
Thanks a lot for that. I think it was a very thorough overview. So,
Thank you.
Thanks a lot. As Enzo said, oh, yes, questions. Is that better? So, is there any questions from the audience? If you don't mind, can you come and ask your question here? Otherwise, Enzo is not going to get the exact question, please. Can, now you can.
Hello.
He's speaking to
Hello.
I've got two questions. I think the third one is not very important at the moment, but the first one is concerning the area of interest. Do you have any facility of uploading a KML file to sort of delineate the area of interest? And the second. Okay. The second question, I think you could answer both of them at the same time, is are you able to model a satellite by getting the TLE data from, let's say, a database and then just reading from there and then model the orbit of that satellite? Thank you.
Okay. Thank you. So yes, we can perform both cases. So we can import a KML file to define an area of interest, but not only an area of interest, we can even define a track that is being followed, for example, by a vehicle. While for the
can I add just one thing?
Yes.
Also, thanks, Enzo. I mean, also on KML and KMZ, obviously it's very easy to import them. So even drag and drop into the 3D window will allow you to import that. Then there's even the possibility to promote them to actual STK objects, which means, as Enzo was mentioning, a KML that represents a specific region or area could be actually promoted to an area target. A KML or KMZ that represents, let's say a trajectory, a path, or whatever we wanted to consider for a track, that could be, in that sense, a track that represents the flight of an aircraft or the route of a ground vehicle, could be promoted to either ground vehicle or, an aircraft, depending on what you wanted to use it for, and then you can perform analysis on it. So that's the first thing. Sorry, Enzo.
No, thank you. While for also the satellite, we can we have several ways to define the satellites, starting from what I see. Let you see. So the orbit, the orbit wizard or the standard object database, but we can even add our own TLEs, or we have Astrogator in order to define mission planning.
I wanted to add also one thing that I forgot about, sorry. For what concerns area of interest, not only KMLs or KMZ, but as example, even shape files, which is usually a very common format files that is, file format that is used to represent areas or polygons, generally speaking. Those as well could be inserted into STK to define the area of interest and a possible polygon then for your analysis. For what concerns instead what Enzo mentioned about the trajectory of a spacecraft, as he highlighted, Orbit Wizard is definitely one of the options. TLE is definitely another option. Ephemeris, so simple description of time, position, an orientation of a spacecraft could be imported in that sense. So position means X, Y, Z, velocity X, velocity Y, velocity Z. Then we have obviously high fidelity propagators that we can use to represent as well spacecraft with specific force models. For what concerns TLEs, we didn't obviously have the chance to show it in this particular workshop, but we do have a database inside STK that's basically the Cellus-Track database that we augment with additional information in order to filter out the database in ways that are more meaningful, which means if it's operational, non-operational, if it's an Earth observation satellites, if it's a communication satellite, if it's a different type of scientific mission or whatever. So in that sense, but anyway, we implement the full public Cellus-Track catalog inside STK, and that can be used in an online fashion or even in an offline fashion, meaning if you're connected to the internet, you get it the latest updates. If you're not, you could basically download from our website the latest catalog and paste it on the machine that is offline to be used with the latest information. Hope this helps.
Thanks, Roberto and Enzo. I think that definitely helped. Is there any other questions from the attendees? I think here's another one, so just wait a few moments.
It's a very obvious topic.
It's fine, go for it.
Hi, thanks for the presentation, Enzo.
Hi, thank you.
My question, I think, I suspect I already know the answer, but I just want to know if the White Sands ground station that you have there, the elevation mask only has, it seems like you only have access to the south and not to the north. Is there mountains in the way? What's going on?
Okay, we can see for now is like, okay, it's two. It can be for two reasons. One is, okay, we have effectively a bit of mountain, but in this case, the terrain server has been disabled for these training. But we even have, you can notice that effectively we have mountains for the azimuth elevation that we have here, but it can be even the sensor aperture. So we have a sensor aperture that can be just directioned for 180 spacing here. And maybe we don't have from the other side the same sensor. So technically, the azimuth elevation is up to the known structure of the facility. So we have the possibility that the user can define its own azimuth elevation mask, and can be related to the facility, to the architecture of the facility, also and also to the
terrain models around it. In those cases, you can see, specifically to answer your question, this goes along the lines of what Enzo just mentioned. This is most likely a facility characterization that comes from the architecture of the facility, which means it's possibly used because it's a hard cut, as you could see, at 180 degrees. So in that sense, it's just used to point towards south, most likely because there might be, I don't know, just a dedicated environment for the south pointing capability, and so other facilities are pointing north. On the other end, there might be a limitation that you can input based on how the physical representation of the ground station is set up. The antennas cannot gimbal more than a certain type of angle, and so that's represented as well inside the body masking representation that you see here. But then this is just a representation that is then used for analysis. You can even specify angular limitation, angular constraints that are not physically visible in this particular representation, but they're used at the analysis level. So in that sense, it might be things that you could do custom-wise that says the minimum elevation angle should be 10 degrees, the azimuth should be between, I don't know, 0 and 30 or 40 and 60. That's it.
10 and 50, for example, and we can set a constraint. And well, we have another check.
Exactly. Yeah, exactly. So the azimuth elevation graphical representation that you see here hasn't changed because that's actually belonging to a file that is taken into account, which is a terrain mask. But on top of that, we added an additional constraints for elevation. One of the things is important to say is these type of information for facility are coming together with, I mean, the body masking is coming directly with the facility when it's part of a facility database, meaning that we have associated body masking file coming from terrain environments or other limitations into the facility database. But then you can create your own based on the ground, the terrain around it, or I mean, whatever you're interested in. To simple. It's a simple ASCII file. And this is a great point to describe the fact that STK has a very, very open architecture for you to be able to introduce a lot of custom inputs. And also, I mean, as example, azimuth elevation, in this case, is a simple ASCII file that is described as angle of azimuth, angle of elevation for the specific location, and is associated to that. So you can create whatever you like.
Okay, thanks for answering those questions, Roberto and Enzo. I'm looking at the audience. I think that was the last questions.
Okay.
Just gonna.
Thank you for all the questions.